Welcome to our deep dive into the fascinating world of the periodic table. It's not just a chart on a classroom wall, it's a roadmap, a decoder, a storybook of all the stuff that makes up, well, everything. Today, we'll uncover some intriguing facts and details about the elements and their arrangement. We'll find out how scientists discovered new elements like the story of seaborgium, and how the periodic table helps us predict how elements behave. Get ready to unlock the secrets of the periodic table. We'll travel from the lightest element, hydrogen, all the way to the heavyweights, and we'll learn why their place on the table matters so much. You know how much I love elements. Each one has its own story, its own personality. Take seaborgium, element number 106. It's named after the amazing scientist Glenn Seaborg, and it's a big one. We're talking a nucleus with 106 protons. Now, seaborgium is not something you just find lying around. It's synthetic, which means scientists have to create it in a lab. And it's radioactive, which means it decays or breaks down pretty quickly. But here's the thing about seaborgium, it's a testament to human ingenuity. We can create new elements, and that's just incredible. And you know what else is incredible? The periodic table predicted its existence before we even made it. That's right, the table's like a giant element recipe book. So next time you see seaborgium on the periodic table, remember, it's a tiny piece of matter with a giant story behind it. Let's travel back in time to 1869. Picture this. Dmitry Mendeleev, a Russian chemist with a wild beard, is hard at work. He's got cards spread out everywhere, each one with an element and its properties. He's arranging and rearranging, trying to find a pattern, a way to make sense of all these elements. And then, boom! He cracks the code and creates the first periodic table. Mendeleev's table wasn't perfect, but it was revolutionary. He even left gaps for elements that hadn't been discovered yet. And get this, he predicted their properties with incredible accuracy. Think about that, predicting the existence of something you've never seen before. That's the power of the periodic table. Mendeleev's table laid the groundwork for the modern periodic table we use today. He gave us a tool to understand the elements, their properties, and how they relate to each other. So thanks, Mendeleev, for the amazing gift of the periodic table. Okay, let's talk about the heart of the periodic table: atomic numbers. Every element has one, and it's like their fingerprint, totally unique. The atomic number tells you how many protons an atom has in its nucleus. Remember, protons are those positively charged particles hanging out in the center of an atom. Hydrogen, at the very top of the table, has an atomic number of 1, meaning it has 1 proton. Helium, next door, has an atomic number of 2, so 2 protons, and so on. Now here's where it gets really cool. The periodic table is arranged by increasing atomic number. That means as you move across the table from left to right, each element has 1 more proton than the one before it. This arrangement isn't just about keeping things tidy, it reveals patterns in the element's properties, which is super helpful for scientists. So the next time you look at the periodic table, remember that those little numbers at the top of each element box are the key to understanding the elements and their behavior. Chapter 4, Copper, element 29, and a big deal. Let's talk about copper, element number 29 on the periodic table. You've probably seen it in wires, pipes, and even those shiny pennies in your pocket. Copper is what we call a transition metal, and it hangs out in the D block of the periodic table. Now, the D block is kind of like the heart of the table, and it's full of metals with some pretty amazing properties. Copper is an excellent conductor of electricity, which is why it's used in everything from your phone to the wiring in your house. Plus, it's a great conductor of heat, making it perfect for cookware. And here's a fun fact. Copper is naturally antimicrobial, which means it can help prevent the growth of bacteria. That's why it's been used in hospitals and other places where cleanliness is super important. So, the next time you see something made of copper, remember that shiny reddish-brown metal is more than meets the eye. It's an essential element with a long history and some pretty incredible properties. Chapter 5. From lithium to fluorine, a periodic trend. Have you ever noticed how things change gradually as you move across a row on the periodic table? That's no accident, that's a periodic trend. Let's take a trip across the second row, starting with lithium, element number 3, and ending with fluorine, element number 9. Lithium is a soft, silvery metal that's so light it can even float on water. But as we move across the row, things start to change. The elements get smaller and their personalities shift. By the time we get to fluorine, we've got a highly reactive gas that wants to bond with almost anything it meets. This trend from bigger and more metallic on the left to smaller and more non-metallic on the right is all about something called effective nuclear charge. Basically, as you move across a row, the atoms get more protons in their nucleus, which pulls the electrons in tighter, making the atoms smaller. So, the next time you travel across a row on the periodic table, remember that you're witnessing a gradual but powerful change in the element's properties. Chapter 6. Newland's Law of Octaves and Almost Breakthrough. Before Mendeleev's famous table, another scientist named John Newlands was trying to make sense of the elements. He noticed that when elements were arranged by atomic mass, similar properties seemed to repeat every eighth element. Kind of like musical octaves, get it? He called this observation the law of octaves, and while it wasn't perfect, it was a step in the right direction. Newland's law of octaves worked pretty well for the lighter elements, but as he moved to heavier ones, things started to break down. It turned out that atomic mass wasn't the perfect way to organize the elements. But Newland's work paved the way for Mendeleev's periodic table, which used atomic number instead. So, even though Newland's law of octaves wasn't entirely accurate, it helped scientists get closer to understanding the periodic nature of the elements. Remember, science is all about making observations, testing ideas, and sometimes even making mistakes. It's all part of the process of discovery. Let's talk about a scientist who made a groundbreaking discovery that changed our understanding of the periodic table: Henry Moseley. Moseley was working in the early 1900s, and he was using X-rays to study the elements. He discovered that each element emits X-rays at a unique frequency, and this frequency was directly related to the element's atomic number. This was a huge deal. It meant that the atomic number wasn't just a random number assigned to an element, it was a fundamental property of the atom itself. Moseley's discovery led to the arrangement of the periodic table by increasing atomic number, which is the way we still organize it today. Thanks to Moseley's work, we have a much deeper understanding of the elements and their properties. His discovery helped solidify the foundation of the periodic table as we know it. Remember Dmitri Mendeleev, the guy with the beard and the cards? He arranged his periodic table based on increasing atomic mass, which is the total mass of protons and neutrons in an atom's nucleus. Now, while atomic mass was a good starting point, it wasn't perfect. There were some elements that seemed out of place based on their properties, even though their atomic masses fit the pattern. But Mendeleev was a smart cookie. He realized that the properties of the elements were more important than strictly following atomic mass order. So he boldly switched some elements around, leaving gaps for undiscovered ones, and even predicted their properties based on their position in the table. And guess what? He was right. Elements like gallium and germanium were later discovered, and their properties matched Mendeleev's predictions almost perfectly. Mendeleev's willingness to challenge the status quo and prioritize the element's properties over strict atomic mass order is a testament to his scientific genius. Let's take a trip to Group 16 on the periodic table, where we'll find oxygen, the element we breathe, and its non-metallic family members. Oxygen is a highly reactive gas that loves to form compounds with other elements. In fact, it's the most abundant element in the Earth's crust. As we move down Group 16, the elements become less non-metallic. Sulfur, just below oxygen, is a solid at room temperature, and is used in things like gunpowder and matches. Selenium, even further down, is a semiconductor, which means it can conduct electricity under certain conditions. It's also an important nutrient for humans, but too much of it can be toxic. So even though the elements in Group 16 share some similarities, they also have their own unique properties that make them fascinating to study. From the air we breathe to the technology we use, Group 16 elements play a vital role in our world. One of the cool things about the periodic table is that it reveals trends in the element's properties. For example, metallic character, or how much an element behaves like a metal, decreases as you move across a period from left to right. Think about it. On the far left, you've got your classic metals like sodium and magnesium, shiny and reactive. But as you move across, you encounter metalloids, which have properties of both metals and nonmetals. And eventually you end up with nonmetals like chlorine and argon. Now if you travel down a group, metallic character increases. This is because the outermost electrons, which are involved in chemical bonding, are farther away from the nucleus and easier to remove, making the elements more reactive. So, the next time you're exploring the periodic table, pay attention to the trends. They can tell you a lot about the elements and how they behave. Thanks for joining us on this journey through the periodic table. We've explored its history, its organization, and some of the amazing elements it contains. Remember, the periodic table is more than just a chart. It's a powerful tool that helps us understand the building blocks of our universe. Stay curious and keep exploring the wonders of science.